Assalamualaikum warahmatullahi wabarakatuh. So, in this video, we will continue on chapter 2.2. So, chapter 2.2 is about introduction to pneumatic instrument and electronic instrument control system. So, the content for this chapter is 2.2.1 is converters, 2.2.2 is transmitter, 2.2.3 is recorder, and 2.2.4 is transducer. So I will explain in detail each of these instruments that normally use inside the control system. So the course learning outcome for this chapter 2.2, firstly, students should be able to recognize and define the common pneumatic and electronic devices that incorporated with control system. Second, course learning outcome is students should be able to explain the function and operational principle of electronic devices in control systems such as converters, transmitters, recorders, and transducer. And lastly, students should be able to explain the function and operational principle of air to close, also known as ATC, and air to open, also known as ATO, control valves. Okay, now for introduction. Okay, pneumatic and electronic instrument is considered as a hardware because they manage the data or signal during control process. So basically, pneumatic is air-driven instrument. Meanwhile, the electronic instrument is a data signals. It's used to translate or process the analog data or signal. So for the pneumatic, normally is a final control element. So normally it is attached to the manipulated variable. It used to translate the output data signal from controller into physical action. So basically controller will give the signal in an electrical signal. So this pneumatic instrument will translate the signal from the controller into physical action. For example, to open the valve or to close the valve, to increase the valve to up to how many percent. So depends on the signal given by the controller. So for the electronic instrument, like what I'm saying before, is used to translate the data, process data into digital data, from the analog data into digital data. So why we need to translate this analog data to digital data? Because most of the controllers, the control system is automated and it is operated by the computer base, right? So digital data is more understandable by the microprocessor, also known as a logic circuit. Okay. The close relationship between electronic and pneumatic instrument are to make the control system to achieve their objective. So inside the control system, we have both electronic and also pneumatic instrument. These two type of instrument will work together in order to ensure the process is controllable in order to achieve the set point, the desired target. Okay, first we move to converters. So as we all know that nowadays all not just controlling tasks, our daily life also, normally we use a computer based gadget. We use our mobile gadget, we use computer. So same goes to control system. So the control system, the controlling task is being handled by computer, which is our microprocessor. So all data signal, for example control variable, must be formatted or encoded in digital form so that it can be understandable by computer. So the problem now is we normally use analog data. So analog data is the example of analog data is decimal number system. We have from 1 to 1,000, 1 million. So we have a decimal system to represent a variable inside our daily life. For example, temperature, we have 75, 1,000, 150. So that is a decimal number system. Normally, the digital signal are simply two-state binary level. It may be represented in many ways. For example, 2 voltage, 2 current, 2 frequencies, or 2 phase. So in binary, two-state binary levels, we have 1 or 0. Normally, 1 represent high, yes, or true. 0 normally represent low, no, or false. So digital signals normally represent by this binary, two-state binary level. So type of digital system to translate numbers. So basically we can translate our decimal number system into binaries number system, or octal number system, or hexadecimal system. So depends. So this one I think you all already learned, right? During secondary school, to convert the numbers, base 10 numbers to base 2 or base 8. So let me show you how you can get this one to this one. You can try on your own also. So basically, we have 3, 5, 6. So in order to convert into base 2 numbers, so you need to divide by 2. So 3, 5, 6 divide by 2, you will get 178, right? Okay, show here. So you don't have any remainder here, right? So can write down as 0 here. So we divide again by 2, 178 by 2 become 89. So don't have any remainder. Okay, we divide again 89 by 2. We need to divide until we get the smallest numbers, which is 1. So we will get 44 with 1, remainder 1. So we divided again this 44 by 2, we will have 22, 0 remainder. And we divided again by 2, we get 11. So this 11, we also don't have any remainder. 11 divided by 2, we will get 5, right? So we will have a remainder because 2 times 5 is 10. So we have 1 remainder here. We divided by 2 again, and we will get 4 here. So sorry. Okay, 2 here, remainder is 1, right? Sorry, I need to continue the next page. So we will divide this one into 2 again. So the answer is 1. So we don't have any remainder. So this is the last number. So from here, we change the color. You need to use all of this. It will become your base 2 number. So starting from here, 1 0 1 1 0 0 1 0 0. So this is base 2 number. Same, right? So you can try on your own to get the base 8 number. So basically this is how you want to convert the base 10 into the binary or octal or hexadecimal. Okay, now we move to Boolean algebra. So basically this is a logic gate. Okay, so now I will introduce first what is the type of the gate symbol that we have. We have first equality. So for the equality, normally if we have A and B, A must be equal to B. So if A1, B is equal to 1 also. So next we have complement A. Complement A is opposite. Means if A equal to 1, if A equal to 1, then complement A, that means A bar would be the other opposite. The value is opposite to A. So for your information, we only, for the binary system, we only dealing with number 1 and 0. So for the complement, if A equal to 1, A equal to 1, the complement of A means A bar will be equal to 0. So another logic gate is AND. So AND represent by dotted multiplication. So if we have A equal to 1, B equal to 1, so if A and B, that means we have to multiply. So equal to C. So C will be equal to 1. If we have A0, B1, then C will be equal to 0. Or A0, B0, C equal to 0. So another gate, digital gate is OR. OR is expressed by addition. So if we have A plus B equal to C, so if A equal to 1, B equal to 1, that means both is 1, so C will be equal to 1. If we have A equal to 0, B equal to 0, so C will be equal to 0. If we have A equal to 1, B equal to 0, C will be equal to 1. Okay, so this is the symbol for the digital gate. So AND, you can see the hemispherical tank shape of hemispherical tank. Okay, for the AND, like what I'm saying before, A, B, so the product C, A times B. So for the OR, the shape is like this. So for the OR, A will be plus with B. So this is the digital gate for complement, also known as a NOT gate. So if A pass through the NOT gate, and this value of A will be opposite from the value for the input. So if this A equal to 0, the output will be equal to 1. So we can have also none or nor. So none or nor is a combination of, none is combination of NOT gate and also AND gate, and it will become none. So you can see the difference of the shape here. For the none, we have a circle shape on the top of the hemispherical. So this is none. For nor, okay, we also have a spherical shape on the top of the edge of the OR gate here. So for the none and nor, here we input A and B. So if we have not, the value of A and B will become opposite. That means the complement of the value of input of A and B. So we need to put a bar on top of A and B so that we can see there is a difference of the value here. Okay, now I show you one example of the what is this what is the relationship between this digital gate with the control system. Okay, now we have a tank. So inside this tank we have a level, system, pressure and also temperature. So it is mentioned here the alarm triggered condition when the low level with high pressure occur. So that means low level, high pressure, the alarm will be triggered. This is the first condition. Second condition, the alarm will be triggered when the inside the tank is high level and high temperature. So the third condition, high level with low temperature, high level with low temperature and high pressure. So we can convert this condition, the statement condition, into the Boolean expression. Okay, we can use the AND operation so that we can get the alarm triggered. That means D equal to 1, right? So alarm triggered on. So we can use we can convert this statement into the Boolean expression. Let me explain in detail. So for condition 1, for alarm to be triggered, so that means if D equal to 1, if we want to get D equal to 1, so the condition first we need to fulfill low level with high pressure. So low level is 0 here with high pressure. So high pressure is 1. So here, because we want to get D equal to 1, so this is the multiplication, right? So the value must be the same. So that's why this A at first is equal to 0. But in order to get D equal to 1, we need to have 1 times 1, right? So this A will be the complement of, this is the complement A of the A here. Okay, so second condition, to get D equal to 1, high level with high temperature. So both high level, high temperature, this one the binary state is 1 here, this is also 1. So directly put A and C. So for the third condition, we for D equal to 1, we need to fulfill high level, low temperature and high pressure. So high level is 1, low temperature is 0 and high pressure is 1. Okay, so because we use AND gate here, so basically we need to have all 1. So for A, we can directly use high level because A equal to 1. For C, this condition is 0 because low temperature, so we need to get the complement of C so that the value of C here become 1. So B, directly we take high pressure. Okay, So we need to combine all three conditions using OR operation, so that if any is true, the alarm will sound D1. So we need to combine all of this with the OR gate. So that means this one, condition 1 plus with condition 2 plus with condition 3, so that the alarm will be triggered. Okay, now I will show how to develop a digital circuit by this Boolean expression. Okay, basically we have three variable, which is level, pressure and temperature. We have three condition. So first condition is complement of A and B. So at the level circuit, we need to have a OR gate so that we get a complement of A. So this A must be multiplied with B. So we need to have AND gate. So B here, input to the AND gate here, so that we will get complement of A dot B. Okay, settle for first condition. Second condition, A must be timed with C. So this level and temperature. So we need to have AND gate. So we can see here A and C input to the AND gate, we will get A dot C. Okay, second condition fulfill. Third condition, A dot C complement dot B. So at C signal, we need to have OR gate in order to get the complement of C, right? So here we draw the NOT gate. We will get the C bar, C complement. So at first we can, because all the gate maximum we have two port for input. So for the first AND gate, we times A with B variables, we become A dot B, and then we use another AND gate to time with C complement. So we will get A dot B dot C bar, C complement. So all of these variable need to be, that means all of this condition need to be fulfilled in order to get D equal to 1. So we need to plus all of those conditions. So if we want to plus, we need to have OR gate. Okay, here we can plus A bar dot B plus with A dot C. Like what I'm saying, all the gate we have two input and one output, so we need to separately use the gate. So this output from the first OR gate will be input for the second OR gate. So this one also, and lastly will be the summation of D. Okay, I hope you can understand on this, on how to develop a digital circuit using AND or OR gates. Okay, now we move to the next slide, which is on integrated circuit. So basically this one, if you have a chance to look onto the printed circuit board that we have inside our electronic appliances, you can see there is a integrated circuit IC chip. So basically this IC chip is our logic circuit. Okay, now we move to analog to digital converter. Like what I'm saying before, all the controlling tasks is handled by computer. So that's why we need to convert our analog signal to digital signal by using this ADC. So basically for the analog, it represent by the continuous signal. So this one is discrete signal. So typically an ADC is electronic device that convert input analog signal, for example voltage or current, to a digital number. So digital number is 1, 0, 1, 0. Okay. So this is the schematic diagram for the analog to digital converter. So basically, from our sensor, we will obtain this signal in terms of voltage. So this signal will be fed into the comparator. So this comparator is used to convert the analog signal to digital signal, and it will be sent to control logic. So control logic will be process the information and will send the output, the decision that it will be made, that need to be taken to the shift register. So basically shift register and storage register, this register can be found inside our calculator. So the function of this register is used to manage the movement of the data sent by control logic, and used to store the data at the storage register, and basically this one is used inside the calculator. They store the data inside the storage register, and if they get another data, it will add up into the storage register, and the final data will be sent back to the digital analog converter to convert from the binary data into the analog data, which is in voltage back. So here the comparator compare the output from this digital to analog converter with the input from the analog to digital converter. Okay, so basically the curve response here, this one, the grey color, is a analog signal. Meanwhile the discrete graph here, discontinuous graph here, is a digital signal. So DAC, digital to analog converter, just now we have ADC, now DAC. Function is the same, but it is reverse. ADC to convert analog to digital, DAC digital to analog. So basically ADC convert abstract finite precision number, the red color one, usually a fixed point binary numbers, into concrete physical quantity, for example voltage, current, or it can be pressure also. So digital to analog converter, basically we can calculate the voltage that we can be obtained after we convert from digital to analog. So suppose a n bit digital value is represented as A1, A2, A3 and so on until AN, where AI can be either 1 or 0. So 8 corresponding analog value can be calculated as here. So from the binary number, we can calculate the analog value here. So let's have a look on how to calculate the analog value. So this is one of the example. Suppose an 8-bit digital value is given as, so this is the binary numbers that we get, the signal, digital signal that we get. So we need to convert this digital value to corresponding analog representation using a DAC with VR of 12 volt. So this is specified. VR normally is specified. Okay, so we have here 1101010. So we just input inside this equation. So for the A1 is equal to 1, A2 is equal to 1, A3 is equal to 0, A4 equal to 1, this one A4, A5, A6, A7, A8. So for 0, like A3, 0 times 2 to the power of negative 3, the answer will be 0. So the one that times with 0 can be eliminate first. So we just can get the numbers for A1, A2, A4 and A7, and we add first and then we times. We will get V0 is equal to 9.8438 volt. So this is the calculation on how to convert digital signal to analog signal. Okay, now I move to transmitter or transducer. So transmitter is used to convert the sensor output into a signal level appropriate for input to a controller. So basically the input that match the controller input is, the output of sensor that match the controller input is in a current. So normally the range is 4 to 20 milliampere. So transmitter tend to be direct acting. When the output signal increases, the measured variable also increases. So this is a direct acting. We can say directly proportional. So that's why we can use transmitter. So commercial transmitter have adjustable input range, span and 0. Okay, so what is meant by this one? Let's have a look here. So this is the process measurement, transmission and control signal. So normally in a process we can see the variables like level, temperature, flow, pressure and pH, right? So like what been mentioned above, transmitter have adjustable input range and 0 is here. So basically if we compare in percentage, this is the 0% until 100%. So for the transmitter, it will read the 0 of the transmitter, it will read from 4 milliampere to 20 milliampere. Okay, so I pick one example here. Basically it is equivalent. So for temperature, the 0 is 0 degrees Celsius. It is equivalent to 4 milliampere. So if it's the temperature increased to 50 degrees Celsius, that means it's increased 25 degrees Celsius from overall. So right now 0 is 0 degrees Celsius. The maximum is 200 degrees Celsius. So the span is from 0 to 200 is, the span is 200. So 50% from 200 is 50 degrees, 25% from 200 is 50 degrees Celsius. So for 50 degrees Celsius, for the electronic signal, it is equivalent to 8 milliampere. So if your temperature increase to 50 degrees, 50 percent, that means 50% from the spans would be 100 degrees Celsius. So this 100 degrees Celsius, it is equivalent to 12 milliamperes. Okay. So basically this is how the transmitter operate. So the sensor will read the physical value from this variable level temperature flow, and transmitter will transmit the signal into the electrical signal or pneumatic signal. So we have a transducer. So basically transducer is a combination of the, just now we have transmitter receive input from sensor, right? For transducer, inside that transducer, it have both sensor and also transmitter all in one together. Sometimes in our process, we can use sensor standalone and transmitter standalone, but sometimes we can use transducer. That means inside that transducer they already equipped with sensor and transmitter. You do not need to add up any other sensor. Okay. So basically transducer convert the magnitude of a process variable, for example flow rate, pressure, temperature, level, concentration, into a signal can be sent directly to the controller. So at first sensor detect all of these variable, and then transmitter is used to transmit the signal from the physical signal into the digital signal, into the electrical signal. So this electrical signal will be sent to the controller. This electrical signal can be readable by controller. The sensing element is required to convert the measured process variable into some quantity more appropriate for mechanical or electrical processing within transducer. Okay, now let's have a look on the example. So we have a temperature transmitter that can be adjusted so that the input range of platinum resistant element sensor from 50 to 150. So the following correspondence is obtained. So the zeros for this temperature transmitter is 50 and the span is 100. Remember, the span is the maximum value minus with the zeros. So we will have 100 degrees Celsius. So for the 0% is equivalent to 4 milliampere. So in order to calculate if we obtain the measured value of temperature, for example like 70 here, so we need to convert it into the electrical output, right? Electrical value. So we can use this formula. So we can have this value of temperature. We input the measured temperature here so that we can get the value of the current, the electrical signal output. This value will be sent to the controller. So example of linear instrument calibration. So basically we will have 0 and also span from 0 to maximum temperature. Okay, so in order to calculate the gain, we need to divide the range of instrument output, which is our electrical value, with the range of instrument input. So input our temperature, we will get the gain value. So now I will show you the example of the current to pressure converter system. Just now we have a analog to digital, digital to analog. That one will be used inside the controller itself. So this current to pressure converter, it is a instrument that will be attached after the controller. So just now, remember, the controller, okay, here the sensor will read the physical value for the process variable, and the transmitter will transmit that value into the electrical signal, right? The electrical value, and then this electrical value will be sent to the controller, and this electrical value will be converted into binary numbers. So from the binary numbers inside this controller, it will be converted back into the electrical signal. So this electrical signal here it cannot be readable by this flow valve. So that's why we need to convert that current to the pressure, so that this valve will be manipulated based on the change of the pressure. So this one we also can use the we can use this, for example, like the current signal you get 8 milliampere, so the opening the pressure must be converted to 6 psig. Why we use pressure to manipulate the valve? Because normally valve is operated by the pressure. The opening of the valve is manipulated by the air inside the valve. So that air is connected to pressure. So here we can see after the controller, there is a current to pressure converter in order to convert the signal sent from the controller, so that the valve can read the signal. Okay, now we move to recorder or data acquisition or data logger. So this one you can find inside our process control laboratory. So basically this recorder is used to record the response of the process variable that you need to know. For example, temperature, level, concentration, and etc. Okay, so this is the figure that you can find inside our DCS system. Later on during our laboratory you will learn in details on this one. So basically this is the data logger. So this is the example of response that I mentioned. So normally the response of the, for example, I take temperature, so it will record based on the times and temperature. So at certain time there is an increase of temperature, at certain time there is a constant of temperature. So this is meant by response. If sometimes there is a disturbance occur, so your temperature will be increased. So this response based on the setting that you make, or based on the condition, process condition inside your process. So now I move to the final control element. Okay, actuator. So this actuator is mainly used inside every process control loop. This actuator is a device that enable a process variable to be manipulated. So the most common actuator that we use inside the chemical or petroleum process is control valve. So this control valve will adjust the flow rate of material and indirectly the rate of energy transferred to and from the process. So basically, process if we need to control the flow rate of the material, if our objective is to control the flow rate of material, basically we not just control the flow rate of material. Indirectly, if we control the flow rate of material, we in the same time we control the rate of energy transfer to the system. Okay, the control valve component consists of valve body, trim, seat and actuator. So we will discuss on pneumatic valve in detail after this. But for your information, instead of pneumatic valve, we can also use motor, pump in order to adjust the manipulated variable inside the control system. So there are many different ways to manipulate the flow of material or energy into and out of the process. For example, like what I was saying before, we have a pump drive, screw conveyor, blower and etc. However, this control valve is a simple and widely used method to accomplishing this result with fluid. So this control valve also known as a automatic control valve. We have two types of control valve, which is air to open or air to close valve. So this type of valve is designed based on safety consideration. This consideration depend on the transducer. So when the power goes off, the transducer signal goes to the lowest value in the range for the direct acting transducer. So logically, do we need open or close valve when this situation happen? So I will explain in detail about this. Air to open and air to close valve. So air to open and air to close valve is used depend on the safety factor of the process, or what is depend not only safety, it's depend on the what we gonna to control also. So this is the air to close. Why we call it as a air to close? Because this is the control valve part. So this control valve part need air supply here in order to close the valve. So if in the emergency case, that means there is no supplies, the supply of the air is being shut down, or the plant shut down, so the supply of air cannot move, cannot fit into the control valve. This valve will be open, right? So we can call it as fail open. Fail means if there is no power supply, or the suddenly emergency shut down, or the plant upset, this valve cannot be open. So we can call it as a fail open. So in the case of suddenly the power supply to the reactor is shut down, there is a connection problem of power supply, or there is any emergency occur at that process. So the reactor, the function is our control objective, main control objective in reactor normally is to control the temperature, right? So this fail open valve can be used to manipulate the steam. For example, this is reactor. So this is cooling water, for example. So we need to maintain the temperature inside here. So we use the control valve here, manipulate the cooling water. So if let's say the system is shut down, the cooling water, the valve will be open. It causes the cooling water to flow inside the coil, and it will make sure that the temperature inside the reactor will be cooling down. If there is any emergency, we cannot use air to open valve. Air to open valve is opposite operational as per compared to with the air to close. That valve will cause, okay, let me explain in detail. So this is the air to open valve. That means we need to have air to open the valve. So we need to put in air to open the valve. So in the emergency, if there is an emergency, there is no supply of air, this valve will be closed. That means in the fail situation, the valve will close. So if we use this fail close valve at this reactor system at emergency, the control valve will directly close the cooling water, and it will cause the reactor to heat up. It is very dangerous. It may cause explosion. So that's why we need to choose a correct type of the valve for the correct process. Normally this air to open, or on the other word is fail close valve, is used for the level system. So basically level system, okay, we will manipulate the feed inside the tank, right? Okay, if there is a emergency occur, if we use this fail close valve here, so the feed inside here, if there is emergency, it will directly close the valve, so that there is no feed inside. There is no fluid feed inside the tank system, so that the level will be maintained. If we use fail open valve, which is air to close, the fluid will keep being fed into the tank. It will cause the level to increase beyond its limit. So that shows why engineer design all these two type of control valve. It can be used based on the process that we need to process, and it be designed for the safe operations based on the control objective that we need to be fulfilled. Okay, I hope you can understand to what I'm explaining here. So basically, these two type of control valve is very crucial. So you need to really understand on which situation you need to use fail air to open valve, air to close valve. So inside your final year project design also, you need to really understand on this, so that you can use this type of valve to design your control system later on. Okay, so end of slide. So thank you. If you get any confused, you have any question, you can directly text me or ask me inside our Telegram group. Okay, thank you.